All right, so we are working on our last lesson of Chapter 5, Solving Systems of Linear Inequalities. We have graphed inequalities before. So now all we're doing is graphing a system, which means that we're going to be graphing two lines and we are going to be doing shading. You will need a ruler for this. So if you don't have a ruler, you might want to grab one really quick. So just as a reminder, when you're graphing, it is important that you remember the symbols and what they represent. So if you have a equal sign under your inequality, that means you're going to draw a solid line. And if you don't, that means you're going to graph a dashed line. Okay. So the first thing you need to make sure is that your equations are in slope-intercept form, and they do happen to all be in slope-intercept form here. So the first thing that you are going to do is you are going to plot your y-intercept. So number one, plot your -4 on the y-axis. I still have students plotting it on the x-axis. So plot -4 on the y-axis. Oh, where'd my glasses go? And then you are going to graph your slope. Now our slope is 2. And anytime you have a whole number, you put that over 1. So this is the second thing you're going to do. And so I'm going to rise 2, run 1. Now I can also go down 2 and to the left 1. I had a question on the on a quiz that we took from someone, and they could not understand how when you had a positive that you can go down. You can go down as long as you go to the left, because you're going in two negative directions, which means that makes a positive. Okay, so you can continue to plot your slope. And when you graph this, remember that you can graph, or that you need to graph a solid line. Did I do that right? Oops, I messed up on my dots. Hold on a second. Fix that. Right. That because there's an equal sign, we're going to draw a solid line here. Okay. Now, remember with inequalities, we are also shading. Yeah. There's a line right here underneath the inequality, which means this is less than and equal to, or equal to, really. This one over here is just greater than. So because it's less than, that means we need to shade in the less than direction. So if we look at the y-axis, we need to shade below the line on the y-axis, which is when the numbers get smaller. So we're just going to do our shading here. Okay. All right. So the line and the shading, that was step 3. Okay. Now let's go to the next inequality. Again, we're going to graph our slope, which is +2. So we're going to plot a point at 2 on the y-axis. And then we're going to graph our slope. Remember, we could put it over 1. And this time it's a negative. So that means we have to go in the negative direction. So we could go up and to the left. Up is a positive direction. Left is a negative. So as long as we have one negative direction, we're good. Or we could go down and to the right. Now with inequalities, they don't have to intersect at one point, but they are going to intersect. Otherwise, they don't have a solution. So 1, 2, 3. Now this line is going to be dashed because there's no equal sign underneath the inequality symbol. So when I graph this, I feel like I got 1, 2. Okay, so when I graph this, I'm going to have a dashed line. And then I have to do my shading. So my slope was 2. My shading is 3. Uh, and says that y is greater than. That means when I look at my y-axis, I'm going to shade above that line where my numbers get larger. So my numbers are getting larger on this side of the line. So I'm going to shade here. So do it like this. And so once I get that done, the point of intersection, or not the point of intersection, but the overlapping sections would be your solution. So what this is saying is everything within the overlapping section is your solution. Every single one of these ordered pairs. If you were to plug them into the inequality, it would be true for both. Now, in the blue section here, I could choose an inequality here, and it's only going to be true for my second line here. If I were to choose a pink ordered pair, it'd only be true here. Yeah. And here in the blank section, this would not be true for either one. So if you were to plug those in, that's how that would work. Was it? Really? Was it just a one of them? Okay, and that means that that's review because we have graphed inequalities before. We just haven't graphed systems. Okay. All right, let's go ahead and do the next one. Example 2 is the same process. Now look at this first inequality though. Since we don't see a y-intercept, what does that mean? It's 0. So we could put a +0 here if that helps. But I'm going to graph this one, and I'm going to start with my y-intercept at 0. Slope is 1/4. That means I'm going to rise 1 box, and I'm going to run 4 in the positive direction. Or I could go down 1 and to the left 4. Down is negative, left is negative, making it a positive. And so am I going to have a dashed line or a solid line for this one? Dashed, because there's no equal sign. So I'm going to go ahead and draw my line. Okay. And y is greater than, so that means looking at my y-axis, I'm going to shade above my line. And some of you may be working ahead. That's perfectly fine. Make sure you check your answers, and then when you get to the back, it's the same thing, except you have to rearrange your equations into slope-intercept form. All right, my next equation, I'm going to plot my y-intercept at a +4 on the y-axis. And then I have a negative x. That's saying a -1/1. So I have to go in the negative direction. So I'm going to go up 1 and to the left. I can also go down 1 and to the right. And because I have an equal sign, that means I'm going to have a solid line. So I'm going to draw a solid line here. And then I am going to do my shading. Now my shading is less than, so looking at my y-axis, my line, starting with my line, I'm going to see where my numbers get less than, and they get less than going below it. So I am going to shade. And the overlapping section is right here. Now you don't have to do the highlighting. As long as I can see where it overlaps, you're good. Okay. All right, let's go to example 3. Now example 3 is y is greater than -3. We're missing our slope. So remember, when you have a y or an x here, that just means that, and there's just a number without the slope, that means you're going to plot a point on that axis. So I'm going to plot a point at -3 on the y-axis, and then just draw a line through that. Now, our line has to be dashed on this one. And then when you're done with this, I want you to go ahead and finish this one on your own by graphing the second one. So I want you to finish example. Oh, okay. Hold on just a second. Okay. Uh-oh. Let's see. Hopefully this will stop sharing. Right. There we go. Yeah, so go ahead and finish example 3 and 4 on your own. I'm going to pause the video while you do that, and then we'll come back and check. Okay, so on example 3, check the direction of your lines, make sure they're dashed, and make sure the shaded area is the same. And then same with number 4. Number 4 is just a very tiny section that they overlap. Are there any questions on this? All right, anyone still working on these? Okay, I'll wait for just a minute. Let's go ahead and move on to page 2. Page 2 is the same. So, but we have to rearrange our equations into slope-intercept form. So this is just practice in doing that. So, we are going to, I'm going to do the first 2 with you, and then you're going to do 7 and 8 on your own. So in this one, we have to move 2x over because our goal is to isolate this y. And when we move the 2x over, it becomes a negative. Divide everything by 3 still to isolate that y. So the equation that we are going to graph on this is y is less than negative 2/3 x plus 3. So that's the first one. I'm going to go ahead and rearrange the second one. On the second one, this is a 1x. So I'm going to subtract 1x on both sides because, again, our goal is to isolate that y. And so we have to get rid of everything around it. So we're left with negative 2y is greater than or equal to negative 1x plus 4. And you do not need that 1 in front of the x if you don't want to. Now I have to divide by a negative 2 to get the y by itself. And remember, when you divide by a negative, it flips the sign. Okay, so we have to flip that sign. So we have y is less than or equal to positive 1/2 x, because 2 negatives make a positive here, minus 2. Positive 4 divided by negative 2 equals a negative 2. And so these are the 2 equations we're going to graph on that. Okay. All right, I'm going to go ahead and let you graph both of these, and then we'll come back and check our graphs and move on to number 6. So I'm going to pause the video. Okay, go ahead and check your graph. Notice that that first equation had a dashed line and you shaded below. The second equation had a solid line and you also shaded below. Any questions on this? Okay, let's go ahead and do example 6. We're going to rearrange the equations first. So in isolating the y, I have to get rid of the 7x. So I'm going to subtract 7x on both sides. I'm left with negative 2y is less than negative 7x plus 14. And now I'm going to divide everything by a negative 2. When you divide by a negative, you're going to flip your sign. Did I flip my sign over here? I did. Okay. It's greater than positive 7/2 x minus 7. So this is what you will graph. Okay. The next one, I'm going to subtract 1x on both sides. I'm left with 2y is greater than or equal to negative 1x minus 4. And then I'm going to divide everything by 2. We do not need to flip the sign on this one. So y is greater than or equal to negative 1/2 x minus 2. How's everyone doing with the graphing? Is anyone having trouble with graphing? All right. So I will go ahead and pause the video and let you work on the graphing. We'll check it, and then you're going to do 7 and 8. Okay, go ahead and check your graph when you're finished. Let's move it down. Any questions? All right, go ahead and do example 7 and 8, and we will check both of them in just a minute. And I'm going to pause the video. If you're finished, go ahead and check your answer. So you have a solid line for the first equation and a dashed line for the second, and then a dashed line for the first on example 8, and a solid line for the second. That one was kind of strange because there was only a tiny bit, but if you think about the lines continuing to extend beyond the graph, it would eventually be a wider range of ordered pairs. So, are there any questions on 7 and 8? Okay. Let's go ahead and move to page 3. On page 3, all we're doing is we are reading inequalities. So if you look at example 5, inequality 1, it doesn't matter which one you choose as 1 and which one you choose as 2. I'm going to choose this blue one as number 1 and the red one as number 2. Okay. And so I always like to see, okay, what is my y-intercept? What is my slope? And then how do I identify what y is? So the first thing I look at is the y-intercept. The y-intercept here is at positive 2. So I know my b is 2. Now I find another place where the line crosses an intersection, and it crosses it here at 2, 0. So based on this information, I find my slope. So I'm rising 2 here, and I'm running 1. So and I'm going in the negative direction. So my slope is a negative 2. Now I have to look at my shading. Now, if I look at my blue shading, it's right here. It's above the line, and it's solid. So since it's above the line, it's greater. And since it's solid, it's also equal to. So I'm going to write my equation. Y is greater than or equal to negative 2x plus 2. So let's do the second one. Again, on the second one, I'm going to find my slope, my y-intercept, and what y is. So my y-intercept is down here at negative 2. Now I'm going to find another point where it crosses an intersection, and it looks like it crosses out 1, 2. So now I'm going to create my slope. So my slope goes up 1, 2, 3, and then over 1. So that's it, and it's going in the positive direction. So my slope is 3. Because it's dashed, it's not going to have an equal sign. And I also have to look at the shading. The shading is below the line. I could tell down here, it's not above the line, it's below the line. So that means that y is less than. So y is less than 3x minus 2. Any questions on that? Okay, so for example 6, I want you to work with a partner on this. If you don't know, ask, or if you both want to try it on your own and then check, go ahead and do that. So I'm going to pause the video while you work on this, and then we'll come back and check. Okay, go ahead and check my inequalities. Make sure they match yours. And are there any questions? You're doing good today. Okay. Let's go down to example 7 and 8. It says list 3 ordered pairs in each group that satisfy the system of inequalities in each graph. This should not be too hard. What you're doing is you're trying to look where they overlap and what could be a possible solution. So for example, I know that anywhere within this overlapping section is a solution to the system. So I know that -2, -3 is a solution. Let's see, this is one, -5, -8. And over here is, I could do 0, -3. Those are all solutions. So if you had the inequality and you plugged any of those in, then it would be true. So let's look at this one. Someone give me an ordered pair that would make both inequalities true. 2, 4. Yep. Okay, somebody else. 3, 5. Okay. One more. One more brave soul. 1, 3. Yep. Good. All right, let's go to page 4. I put this one here. I didn't have it originally, but you have a homework question that is similar to this. And so I put this on here just so that you would have an example of it. So let me get that out. Oh, I don't have a copy of it. Oh, here we go. So let's read this scenario here. And they have graphed the scenario. It says a school will request donations of cans of soda and bottles of water to be sold at the next sporting event. They can store at most 180 total beverages. They expect the number of water bottles sold to be less than twice the number of soda cans sold. So they're predicting that they're going to sell more soda than water. So let's look at this. Before we begin, let's fill out the graph. What are they missing on this graph? Yeah, the labels. So let's go ahead and label this. We can label it school donations. I don't know, or and we're also missing the X and Y axis. So based on what it says in the scenario, what would represent our X axis down here? Yeah, so let's put cans of soda, which means the y-axis is bottles of water. So bottles of water. Okay. Now let's answer some of the questions. Which axis represents the number of cans of soda? Yeah, the x-axis. So that's the dependent variable. Honestly, in this scenario, it doesn't really matter which is which, but in this one, cans of soda is on the x-axis. Now it says write the system of inequalities for this problem's constraints. So all it's asking is for you to write the inequality. Now you can write the inequality based on the words, or you can write it based on the graph. Okay, so let's look at the words. It says the school will request donations. Okay, they can store at most 180 total beverages. So if they can store no more than 180 beverages, and we have cans of soda and we have bottles of water, does anyone have an idea of how we would write this inequality. We have a certain number of cans of soda, a certain number of bottles of water, but at most they cannot have, they can't have more than 180 total. Okay, I'm going to pause the video and we're going to think about this for a minute and then we'll come back and share. Okay, Yevon, what did you come up with? Yep, cans of soda, which is X, plus bottles of water, which is Y. It tells us that up here. Has to be less than or equal to 180 because that's as much as they can store. So that would be this line right here because the y-intercept is 180 and it's a solid line less than or equal to. And it's going down by a -1 on the slope. So like if I were to rewrite this, it could also be y is less than or equal to -x plus 180. This would be the graph or the equation from the graph. Okay, so either one of those. So I'm going to make this equation 1 and this one equation or inequality 1. So this is 1. Now we have to come up with 2. So I want you to look at the word problem. We're gonna base it on the word problem and then we're going to change it into slope intercept. So it says they expect the number of water bottles to be sold to be less than. So what variable represents the bottles of water? Y. So Y, the bottles of water to be less than. So we're going to do the less than symbol. Twice the number of soda cans. So how would we write that? 2 times, so 2 times the number of soda cans, which is X. Y is less than 2X. And so that's already in slope-intercept form. Notice that the y-intercept is 0. That's where it starts. The slope is 2 if you count it. And then it's less than, so it's a dashed line and the shading is below. And so that matches our graph up here. So when you're doing this on your homework, use both of these just to verify that your inequality is correct. Okay, let's go down to using the graph. Use the graph to determine which of the following amounts would satisfy the constraints. So in order for it to satisfy the constraints, it must be within this double shaded area right here. It must be within that, okay? So 50 soda cans and 120 water bottles, that would be 50, 120. Okay, that would be the ordered pair. 150 soda cans and 50 water bottles. Or 70 soda cans and 100 water bottles. So I want you to look at the graph and try to figure out which one of these is true. So I plotted the points on my graph, and the only one within the shaded area is C. So you should have gotten C. Okay. Okay, if the school will sell bottles of water for $2 each and cans of soda for $1 each, which of the following options will allow them to raise the most money? Okay, well, we can use our equation x plus y and see what the total price is equals some number, okay? So if we sell 50 soda cans, Oh, I'm doing soda cans first, which is $1, times 1 plus 100 water bottles for $2 each. How much money would we get? Yeah, we would get 50 plus 200, which equals $250. So that's this one right here. So now let's do the next one. What if we sold 100 soda cans at $1 plus 80 water bottles at $2? We would have 100 plus 160, which would give us $260, which is more than A. So I know it can't be A. So now let's do the next one. We have 150 soda cans at $1 each, plus 30 water bottles at $2 each. Well, so 150 plus 60 gives us 210. So it would be B. That is going to give us the most money. Okay. All right. According to the constraints given, could the school request? So we start with 0 and here's 10 soda cans. Could they request only 10? Well, if I look at 10, I could have anywhere in between this amount of water bottles. So right here, we could have at 10 right here, we can have anywhere between here and here of water bottles. It just wouldn't be 180 drinks. So the answer would be yes. All right. Last one. What additional constraints should be considered that would help the school decide if they should request only 10? Now, this one was a little bit confusing, but the constraint would be how much they think that they would sell. So the total amount of each drink they think they could sell. Because if they could sell more than up here of water, they're definitely not going to only get 10 soda cans. That doesn't make sense. It's basically saying they can sell no more than 20 water bottles, right? So if they think they're going to sell more than 20 water bottles, they're definitely not going to get 10 soda cans. Okay. So that's how that problem works. So that is the end of lesson 5.6.